All right, so here's a question that says, let's take a look at SO2, and it says that it gives us a heads up, and it says this molecule exists in a resonance structure. So what that means is we expect that when we draw the Lewis structure, we'll see two equivalent choices or more, two or more equivalent choices for Lewis structure. So it wants us to draw all the resonance structures, and then it asks us, are all of the SO bonds the same? And it asks us to explain it. Well, let's get down to the Lewis structure first. Well, I've got 6 from sulfur, I've got 6 from oxygen, and there's 2 of them. And so that's 18 electrons. All right, so let's arrange the atoms as symmetrically as we can. So I've got S in the middle with oxygen on either side. That's a good symmetrical arrangement. Let's draw a single bond between each of the S's and the O's. Let's reduce our count. That's 4. So I should have 14 left. And so let's think here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, it looks like the oxygens have octets. I've used all 14 electrons, but sulfur is still missing an octet. So what do you do when you've used all the electrons and you're still missing an octet? Well, you erase some electrons and you make double bonds. But doesn't it seem like I could have chosen to make the double bond in this location? The answer is yes, absolutely, I could have. And this is an example of resonance in the introductory chemistry. So here are both of the resonance structures. Resonance structure 1, resonance structure 2. Now, the real structure involves some hybrid between the two. Now, they both have single bonds. They both have at least 2 lone pairs. And so we draw a partial bond between the sulfur and the oxygen on both sides. And we call this one a resonance hybrid. And so this picture that's the resonance hybrid is closer to the real structure. And so now that I've drawn that, I can sort of start to answer the question about, are all the SO bonds the same? If I just focus my attention on one of these structures, I say, well, one of the SO bonds is a double bond, the other one's a single bond, so they're not the same. But if I expand my view out and I look at both of the structures and I say to myself, oh, I'm actually dealing with 2 different resonance structures, and those 2 different resonance structures don't represent the real molecule individually. What they are is the real molecule is a combination of the resonance structures. We call that combination a resonance hybrid. And so I see that in the resonance hybrid, I've got one bond and a partial bond on each side. So when I go back to answer this question, I say, yes, I do have equal bonds. They are the same because the combination of the 2 resonance structures shows me a resonance hybrid where the bonds become equal. That's it.